This paper changed my life. Back in 2016, I was in an environmental science class steeped in climate nihilism, and the only things that mattered to me were the Ego Death album by The Internet and figuring out how I was going to go to college for free. And then I heard about this paper that changed my life forever. Scientists had found a bacteria that eats plastic. Wait, what? From a team of Japanese scientists, the paper is entitled A Bacterium That Degrades and Assimilates Polyethylene Terephthalate. The bacteria is called Eidionella sakaiasis 201F6. Polyethylene terephthalate, or PET, is one of the most commonly used commodity plastics in the world. It makes up the common water bottles, clothing, food packaging, many things. If you don't know, an enzyme is a protein molecule that lowers the energy required for a given reaction to occur. So this PETase takes in PET and holds it in a very specific conformation such that the bonds that make up the backbone or the big long chain that is the molecule can be broken. So PETase takes PET and converts it to MHET and BHET. And then another enzyme called MHATase takes MHET and converts it into TPA and ethylene glycol, which are both relatively benign molecules that can exist in the environment and within the cells without causing any deleterious effects. So where did this enzyme even come from and how did it evolve? PETase evolved from a natural class of enzymes called cutenases. Cutenases break down a molecule called cutin, which exists on the waxy outer coatings of some plants. So amazingly, this enzyme was able to evolve a natural enzyme it had to break down a man-made material that has only existed in the environment since the 1940s. This paper really gave me a paradigm shift and really showed me just what science is capable of discovering in the world, and really gave me hope that there was a future that we could tackle the plastics crisis one day. And this paper also set me on the path to becoming a scientist seriously because I wanted to help with the plastics crisis in any way that I possibly could. This paper didn't just impact me personally. With over 2,000 citations at the date of this recording, this paper opened the floodgates for research of enzymatic degradation of commodity plastics. Even though the paper was behind a paywall and I couldn't understand it at the age of 17, somehow a science communicator got this information to me. And I hope with my science communication efforts that I can pass that information forward and inspire a future scientist as well.